This is just about the mechanics section of the equation sheet and the formulas that you'll see there. A lot of these are ones you're not going to use all the time, but there are some that particularly come up, so I'll try to highlight which ones those are. These first few are equations of motion. They're for describing objects that are undergoing constant acceleration. First one is if you know the acceleration and you want to find the velocity at a later time. The second one is if you know you want to find the position, you know the acceleration and the velocity. And the third one is sort of a funky equation. It's when you know the change in position. That's what this x part is here. And then the other part is if you want to be able to find the final velocity for the equation. This next one that's right here gets used a ton. That's A equals F over M. That's F equals M times A. That's the force equation. The next one is about friction. It's not something that we see very much, but it tells you how to calculate the frictional force. If you know the friction coefficient, that's what mu is in this context. This next one is quite common. It's about centripetal acceleration. So it's just one example of a particular acceleration like we saw before, like A equals F over M. The part that you particularly use this is when we're talking about magnetism, and you want to figure it because charged objects that are moving in a magnetic field tend to move in a circle. This is the force or the acceleration that they move within that circle. So that's where you'd use that, where v is the velocity and r is the radius of the circle. The next one is about the momentum of an object. That's p equals m times v. This next one is, and that one we do use sometimes. This next one is about impulse and momentum. It's not something that we really see a ton of in AP Physics 2. This one does come up quite a bit. That's the kinetic energy formula. It says it's 1/2 mv squared. The next one is relating energy to work. That's not a super common formulation that we use in AP Physics 2, but it's just pointing out that work is change in energy. I suppose we use that when we're talking about thermodynamics as just a basic idea, but we don't usually talk about it in terms of a force times a distance. We just talk about it as a work. This is the power. So this is big P. Don't confuse it with little p. That's momentum. Big P is the power. And power is energy divided by time. So it's basically how fast you're using energy or consuming energy or putting energy into a system. It'd be measured in watts. The unit would be there. These next few or these next two really, I've never seen them on AP Physics 2. They're about rotational motion. So things moving, objects that are spinning, not necessary for us. This one is the general equation for an oscillation. I suppose we see that sometimes when we're talking about waves, but it's shown in a different spot over there as well, so I don't think you'd need it here. These ones all through down here, sorry, highlighting a weird section there. These that go down like this are about finding the center of mass. These are all unnecessary for AP Physics 2. Center of mass, torques on objects, rotational inertias down here. This is about rotational impulse and rotational momentum or angular momentum. This is about the kinetic energy of angular motion. So all of those through here are really not ones that you would ever use. This is the force of a spring down here, this last equation on the left. Again, not something that comes up in AP Physics 2 because we don't really talk about springs. This is the potential energy of a spring as 1/2 kx squared. Again, not important. This one does come up. This is the potential gravitational energy of an object. It's mgh, right, which we've talked about sometimes. You see it in the Bernoulli's equation when we're doing fluid flow, and you have that energy of mgh in there. This is the period of an oscillation. Again, I don't see that. And then these are in AP Physics 2. And then these are two specific examples for it, for a spring and a pendulum. This last one is the force of gravity. And this is calculating the gravitational field and the gravitational potential energy. Again, not ones I think you'd use a lot. So there you go.